Hello everyone and welcome to MakeLearn 360. So in this video I want to solve a simple question to illustrate the concept of the Euler load. Okay, so let's read the problem together and then solve it. We have a solid round bar which is 3 meters long and then 5 centimeters in diameter, which is being used as a strap with both ends hinged. We are to determine the crippling or collapsing load, and that is the value of our Young modulus. Okay, so think about this solid round bar as having a round bar here, and then this bar that we are talking about is having this length over here, and then it's given by what? So L is 3000 millimeters. Okay, let me just write the values. L is 3000 millimeters, which is the same as 3 meters. And then the diameter is 5 centimeters, which is the same as 50 millimeters. So now what do we have to do? Because he said both end is hinge, it means that there is some form of some hinge at both ends. Now with both end hinge, the Euler load for crippling, what's the formula? So without wasting much time, let's quote the formula. If both end is hinge, then the Euler load is actually pi squared EI over LE squared. Okay, so pi squared EI divided by LE squared, where LE is the effective length. Now if both ends are hinged, then LE is actually the same as the length. So but then what is the I? The I is the area moment of inertia. If I have a solid round bar, it will have a cylindrical cross-sectional area, or let's say a circular cross-sectional area. So it is going to be pi d4 over 64. You can also write this as 1 out of 4 pi r to the power 4. But since we are given the diameter, we can see that the area moment of inertia is pi times 50 to the power 4 divided by 64. So that's going to be what? So our I is going to be okay, so pi multiplied by 50 to the power 4 divided by 64, and then I will get 306,796.16, or let's say 306,796.16 millimeters to the power 4. So that is our I. Don't forget that our E is already given here. So the E, which is the Young's modulus of the material, is Newton per millimeter squared. All right, so then simply put, our Euler load for this problem is pi squared E, which is 2.0 times 10 to the power 5, I, which is 306,796.16, and then I will divide the whole of this by the effective length, which is the same as the length, which is 3000 millimeters. That is for 3 meters, so squared. All right, so that is pretty much simple, right? Okay, so that's the answer for you. I want you to pick your calculators, and then let's do this together. So it's going to be what? So pi squared multiplied by 2.0 times 10 to the power 5 multiplied by 306796.16 divided by 3000 squared. So basically the Euler load is going to be 67.3 kilonewtons thereabout. So 67.3 kilonewtons. Okay, so that is the Euler load for you. Thank you very much for watching. But then sometimes some of the problem they will say 2 decimal place. So in that case you can decide to go 0.288, all right, but it doesn't really change anything. So that is the solution for you. Thank you.